Good afternoon, everyone. Welcome to the final session for the day. This is in the green area. So if you have any questions, please put them in the green Slack channel. Everybody have a good Star Trek? Yeah. Looking forward to the movie? So popcorn and such is available. Well, some people have gotten it now. I have been told that your ticket gives you a bag of popcorn and a soda. So if you got your popcorn now, then you got your popcorn. Additionally, the trailers start at 5:08. The movie starts at 5:30, just to be aware. The, let's see, 1, 14, and I think 16 are the ones that are not open. The rest of them are. And without further ado, I present Jared Olson, developer for your talk.
All right. Thank you, Matt, for that introduction. Like Matt said, we have the Slack channel is open. I posted in there a few minutes ago, hopefully it didn't get pushed up, a link to my slides that are out there on GitHub, so you can get to those, as well as all the code that we're going to dive through today. So this is Build Your Own Voice Assistant. My name is Jared Olson. To give you a little bit of history on me, I'm a developer, been in Columbus, Ohio, doing software for 11 years, 12 years, something like that. I currently work for Pillar Technology, and what kind of started me down this path of building your own voice assistant and why I wanted to come up with this talk was I'm working for Pillar in their product division, so they're trying to spin up products. They've traditionally been a consulting company, but doing products is what I do. And in one of our products that we were building a learning platform to help teams and companies kind of organize their data and share knowledge across the teams and across companies. And one thing that we did was promote, hey, why don't you upload videos of you doing things, screencasts, whatever. And inherently, users are just terribly lazy, right? They just want to do the minimal amount of work possible. So they just want to upload the video and be done with it, right? They don't want to fill out and say, hey, these are the keywords, right? This is a DevOps talk, or this is about MySQL. They just want to say, here's the video, I'm done with it. So I started down the path of trying to figure out how can I transcribe these videos that people are uploading into our systems so that we can start to extract kind of the metadata or get some of the content out of a video file. So I went out to the Google and started doing that to say, hey, how do I transcribe videos? There are a lot of services out there that will take your videos and play them for a person, and a person will sit at a computer and sit there and transcribe your videos, which is probably horribly inefficient, slow, expensive, and insecure, right? So I'm like, there's got to be a way that solve this problem. So I start Googling some more, and I found that Google Cloud, their cloud services provide a nice transcription service. IBM also provided a nice transcription service. So that's kind of how I started this. And I thought, wow, this is actually pretty easy when I got down to it. How do I build this into a talk? Because I probably can't just talk about, oh, I transcribe videos. Ta-da, right? So if you think about building a voice assistant, transcribing is pretty much the first step that you'd have to do, and that's kind of what this talk started. So I do think that there are use cases for building your own voice assistant. So we're not building Alexa skills or anything like that today. We're doing everything all ourselves. So if you're in the retail business, for instance, and you want to have a voice interaction with your customers, you may not want to pay money to Amazon to do Alexa for Business, right? So there are use cases for it, but there's also learning to be had with the aspects that we have to do, right? So I had a problem that I would solve with the information that we're going to talk about today of transcribing audio, right? We're going to do some natural language processing, and we're going to generate audio from a text as well to kind of build out our voice assistant. So, the overarching talk is building your own voice assistant, but there are pieces in here that could be useful on your day-to-day job as well. So what do I mean by a voice assistant? Well, raise your hand if you've used one of these services before, right? If you didn't raise your hand, you're probably in the wrong room, because we've got pretty much the whole gambit here of Alexa, Siri, Cortana, Google, right? I'm sure we're all pretty familiar with at least one of these, if not all of them. And kind of the general interaction between those looks like this.
Hey Siri, what's the weather in Columbus, Ohio? degrees in Columbus. Expect mostly clear skies starting in the afternoon. Today's high will be 46 degrees, and the low will be 35.
So there we asked Siri a question, and I'm sorry if that triggered your phone to ask it what the weather was, but we said, hey Siri, what's the weather today, right? She responded with, here's an audio, right? Reading through that text, here's some text, and here's some imagery, right? Not all voice assistants have a screen that you can look at, so audio always has to be there, but if there is something that does have a screen, imagery, or some text to go along with it is always nice to have. So if we break down kind of the steps of what's happening when we talk with our voice assistant, the first thing is usually the user, like me, talking calmly into a microphone, right? Because we never have to yell at these things. They always understand us on the first time exactly. That data then gets sent up to the almighty cloud where magical processing happens, right? A response is generated, so audio, data, imagery, things like that, and it comes back to a speaker, or if the device that I'm using has a screen on it, that imagery and text will be shown to me as well. So what we're going to be focusing on today is the cloud aspect of this. So we're going to be building out all the steps to do this. So we're not going to be talking about a Raspberry Pi hooking up a microphone and a speaker and things like that. We're going to be more so focused on the cloud aspects. So if we break down kind of the individual steps of what it is that we have to do to build our voice assistant, the first thing would be transcribing the audio into text, right? Because if I just send a byte stream of audio into some process and say, hey, give me something out of that, right, it's probably going to be pretty much useless to us. So we have to extract the text out of it to understand, hey, what was just said? So in that example that I had with Siri, we want the text, what is the weather in Columbus, Ohio? The next thing we're going to do is we're going to run it through some natural language processing, right? Just having a string of text, although good, right? I don't really want to write the regex that starts picking out pieces out of that text to try to decide what it is that I want to do and strip out the pieces of information out of that. So we're going to run our transcription through some natural language processing to help give us some of the data that we need to fulfill our request. The next part will be taking action. So this will be the example we're going to build out is building weather information. So we'll go out and get some weather information and bring it back. And lastly, we're going to respond to our service with audio and data. So what exactly are we going to build today? Well, pretty much everything that we have today has the ability to talk HTTP or the ability to talk to something that can talk HTTP, right? So we have computers, we have devices, we have watches, almost everything we have has a speaker and a microphone on it. And if we have IoT devices that maybe they can't natively talk HTTP, they can probably talk to something that can talk to HTTP. So we'll be building out an API that would allow pretty much any device that we wanted to post up audio and get back a response. We're going to configure that API to utilize a cloud function, which was basically just our backend service, and we'll dive through that. And we'll set up some services to interact with, right, to do all the heavy lifting for us because I'm a developer, I'm lazy, right? I want to do as little work as possible. So we're going to be configuring these things. We're going to configure out some services and configure up our API. We're going to code a front end to interact with our API that we're generating. We're going to code up our cloud function and the way that it integrates with the services that we configure. So where are we going to build this? Well, as I kind of alluded to, we're going to build it in IBM's cloud. So why IBM's cloud? It solved the problem that I needed of when I was trying to transcribe video information and extract data out of it. I will fully admit that I would probably label myself as like an AWS fanboy. The reason that I didn't do this in AWS is that at the time, they didn't provide a service that allowed you to do the transcription piece. I believe like a month or two ago, they finally released a service that does do that. So you could probably achieve this in AWS or in Google Cloud as well. We're going to be using IBM though. And I also don't get paid by IBM, by the way, for doing this. But. All right, so what is a cloud function? Well, a cloud function is part of something you would call, that fits under the umbrella of serverless architecture or function as a service. It's defined as a stateless compute containers that are event triggered, may only last for one invocation, and fully managed by a third party. So we're just trying to build out a service here to basically handle our request for us, so that I don't have to set up a Linux server, configure some sort of Apache, put in a jar file, and do things like that. Just takes away some of the heavy lifting for us. So if we jump in to the Cloud Console in IBM, we can get the whole catalog here of things that they provide us, and we can see that they have something here in the left-hand nav that says functions. So we'll click on that guy. We can see that we only have one option here of functions, so we'll click on that to set up our function. So here's some marketing information about how you would go about setting up a cloud function. I'm a developer, I just click on things though, so I'm just gonna start creating stuff. And we have three options here. The one on the right, would allow you to configure a trigger. That's not what we want. One in the middle would allow you to create a sequence. So if there was a couple of things you needed to do in sequence, you could do that. That's not what we want. One on the left of creating an action, right? If you want to wire this up to an HTTP endpoint, that's what you want to do. So we'll create one of those guys. So when we create our cloud function, there's very little that needs to go into setting it up. We basically select a runtime at the bottom there, so we're going to use Node.js 8 and give it a name and give it a package. So package default is fine for right now, and I'm going to give it a name of speech to text. And we'll click create. So now we have our cloud function all set up for us. Great. So you guys can see that code, right? No, probably not. We'll zoom in a little bit. So the function by default just gives you some code to help you get started. And you can see that right now, JavaScript function main takes params and returns a JSON of message hello world, right? Nothing too earth-shattering there. So if we invoke this function right now, the response we should get back should be a JSON with message of hello world. So we'll leave that there for now until we come back and have some services that we need to interact with. But we need to set up an endpoint for this. So we need to configure our function that we just created to be enabled as a web action. So we'll click that little box and click save. And now we can utilize this as a web action. If we click on the functions there, kind of in the top left, we'll get back to our list of functions. And in the left-hand nav, now we have an option for APIs. So if we click on APIs, we can start to just generate our Cloud Functions API, right? So again, I'm a developer, I just click things, blah, 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 right? And here, again, we need to set up our API. So we'll give it a name, we'll give it select a domain for it, which will just use the default, and a base API path, which will use /API. So we need to configure an action now. So we click on that button, gives us a little dialog. Then we select a path. So we're going to do /speech to text. We're going to say this is going to be a post, put in our default package, and when that API gets invoked, we want it to go to that cloud function that we created, which is called speech to text. And then the response type coming back is going to be application JSON. So that's kind of doing the wiring up between our API and the cloud function that we set up. Click save on that. Scroll down to the bottom of the page. We need to make sure that cross-origin resource sharing cores, the last option there, is enabled on this, because where we're going to be doing this from, localhost, is not the same domain as where this service will be hosted. So make sure that's collect and click on save. Cool. So our API is set up. It's wired up to our cloud function now, which is our back-end service. And we get this nice, giant, long URL across the top there, which looks something like that. So if we curl that guy, we can see that we get back that just kind of base response that we had in there to begin with of message hello world. Right? So now we've got our RESTful API configured. So we've got a URL that we can post to, but right now it's just returning a JSON of message hello world. We've done the wiring up with our cloud function. Right? So if that doesn't make sense to you, don't get hung up on it. Right? That's not the total intent of this talk. Just try to think of this as we've set up a Rails application with one endpoint, right? We've set up a Node Express application with one endpoint, or Spring Boot application with one endpoint. But I just wanted to go through that because it is kind of where we're going to be building out all of our interaction with the services we create. So, all right. So next, we'll start developing the front end, and you guys are in for a real treat today. I don't usually brag, but I am an accomplished UX designer. So we can see that this is the front end we're going to build. we got a header, an image, and a diff, pretty much. So I was obviously joking with being an accomplished UX designer. So we're going to build out some HTML here to interact with our cloud service that we're going to create. So again, you probably can't read that, so we'll zoom in a little bit. And I'm trying to keep it as basic as possible, so this is going to be HTML, use a little bit of jQuery, and a little bit of JavaScript stuff in here. So hopefully this isn't too earth-shattering, right? We've got our image, we've got a header, so we click on the record button, it'll do some stuff. The heavy lifting is really being done by this thing that I found out on GitHub, this Opius recorder. So that's going to be doing most of the work for us. It's a library that I found that allows us in HTML to natively record audio, save it as a WAV file so that we can use it later. So if we scroll down a little bit, we can see that we're wiring up a click event listener. So when we click on that giant record button in our beautiful UI that we have created, it's going to start the recorder. It's going to wait 4 seconds, I think is what I have in there, and then it's going to stop. Move down into the next block on that. You can see we're doing the initialization of that recorder library that we used. And again, that guy right there is doing a lot of the heavy lifting for us. That's what helps generate our WAV file for us. And we can listen to some other events in there. So we get the events of start, stop, stream error, stream ready, and things like that, right? Those aren't terribly useful for us for this demonstration purposes. The one that we care about is the one that is data available, right? So that last one down there. So what we're going to do is when the data is available, so the recorder that we brought in is basically said, hey, I'm done. Here's your data. This is the audio file. We're going to create a blob, and we're going to post that guy to our API that we created and pass it along. When we get a response back, we're just going to show it on the screen. So we're going to be sending JSON back primarily so that we can see kind of how the individual pieces of this that we're building work. Lastly, we just have a couple of CSS styling things so that when we click the button, it kind of goes opaque for a little bit. Move on from there. So that was building out our front end and how it's going to interact with the API that we have created, right? So the first step of what we need to do is transcribe audio into text. So we'll go back to our IBM Cloud console here, and we can see if we look at the left-hand nav, the place that we're going to be is underneath the Watson tab. So when I say IBM Watson, what's the first thing that comes to your mind?
Quickly, Wilson.
What's that? Come quickly, Watson? Jeopardy. Winner. Right there, right? So in 2011, IBM took on Ken Jennings and Brad Rutter in Jeopardy. So they built an AI, bot that actually competed live against those two. And if you don't know anything about Ken Jennings and Brad Rutter, I think each of them have won at least over $1 million, possibly over $2 million on Jeopardy. So they're like the two Jeopardy champions, and IBM built a computer that beat both of them pretty handily, I think, too. So the cool thing about that is they probably spent millions and millions of dollars building that thing, and now they expose a lot of the underpinnings of what they did there to us as developers to use in their cloud services, which is really cool. So we don't have to spend millions of dollars doing research. We'll leave that to IBM, right? So in the Watson catalog, here's all the stuff, and pretty much anything that they have that's AI-ish, they just lump in underneath Watson. Whether or not it actually was used with Watson, I'm not sure. But that's where they put all that data, or all the services that you can create, sorry. So the first thing we need to do is we're going to create a speech-to-text here, right? That's the first step in building out our voice assistant. So we'll click on speech-to-text, and we kind of get our options here of what it is that we want to build. So it pre-populates all that for you, but you can select a name, give it a specific name, or choose a different region, something that's closer to you or closer to your users. Select a package if you want, and the light pricing will work for what it is we're trying to do. And I will come back and talk about pricing later on all the things that we're building here today. So we'll set those up and click save, or create, sorry. So now we have a service. Great, what do we do with this service? Well, this page tells us, here's how you would interact with this service. Here's the things that you need to do to set it up, blah, 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 right? So it is secured, so we do need to set up security credentials so that we can interact with our instance of this service that is running. So we'll click security credentials, get a screen like this, And we'll say, give me some new credentials. Yep, Adam, cool. And now I've got security credentials, which I masked because I don't think I can trust any of you guys here. Right? So we'll copy those guys, the username and the password, because we're going to be using them later, and dive back into our server-side implementation, our cloud function. So you can see now this looks a little bit different than just returning a JSON of message hello world, or whatever it was that was there. So we'll zoom in a little bit so we can see that better. So the first thing that we're doing up there on line 1 is we're bringing in a library that IBM provides to us, the Watson Developer Cloud, and specifically the speech to text underneath it, right? We're also going to use the stream library to do some of the processing on the audio file. And if we look down at line 7, you'll notice that the first thing that we're doing is returning a new promise. So the way that IBM's cloud functions work is if you're doing anything asynchronous inside of your process here, you need to return a promise. And so whenever it is, whatever you're doing is done, you need to resolve that promise, and the response goes back to the caller, right? Or if you reject it, they'll get a 500, whatnot. So that's the first thing we're doing. So inside of there, we're going to instantiate our speech-to-text object here with our username and our password that we copied in from the last place. Now you'll notice that there's nothing there except we're referring to this params thing. Well, how does params magically have our username and password on it? I will show you that in just a second. It's not complete magic, but the params for the most part represents the HTTP request coming in. So on line 13, you can see that we're starting to pull the OW body off of that guy so we can get the data, doing some stream stuff, say, hey, base 64 to code this thing, and now line 18, I've got audio, right? So that's bytes of that audio stream coming in. So we can now take that guy and set up some parameters to make our request to our service that we configured. So we'll say, hey, here's the audio, it's of type wave, and I do want timestamps coming back on this information. So we'll call speech to text recognize, pass those parameters in, and whatever comes back from that, if there's an error, we'll reject our promise, which would cause a 500 in our server. If not, if it's successful, we want to resolve with the data that came back just raw from our speech to text service. So like I said, that stuff up there with the username and password is not magic. You do, when you configure your cloud function, have the ability to set up parameters, which are pretty much just environment variables, which are very useful for things like username and password, right? So I can put those in there, and I don't have to expose them inside of my code or check them in with my code. So we switch back to the front end. Remember, basically what we're doing is whenever we get data, we're going to take that, we're going to post it to the API that we created. When the response comes back, we're just going to log it on the screen since we're getting JSON back. So the first strike at building out our voice assistant would look something like this.
What is the weather in Sandusky?
So that posted the data up to our service, did the speech to text, the JSON comes back, looks something like that. So all the way down at the bottom, you can see, not all the way, 4 lines up from the bottom, you can see that we have a transcript, right? And the transcript says, what is the weather in Sandusky? Cool. Also that comes with that is the confidence, and you can see that it's 96.4% confident that that's what I said. That information is extremely useful, right? Because if there's a lot of noise, or if there's background, or I was talking really fast and you couldn't really understand me, right? They may be less confident in the transcription that they did, and they'll tell you that. And that's way cool, because for whatever it is that you're building, you know, maybe you need super high confidence that the transcription is correct, right? If you're transcribing doctor notes, for instance, you probably want to be pretty accurate with what you're doing and throw away stuff that is not super accurate. Since we asked for the timestamps, we also get the timestamp information. So you can see that the word what was said from 0.49 seconds to 0.88 seconds is from 0.88 to 106 and so forth, right? That information for what we're building here today isn't super useful, but for my use case, I greatly needed that information, so I wanted to show it here today. So that way you can take some audio and you can start even building out caption files for your video if you wanted to, which is pretty cool. So what we've done is we've configured up our speech-to-text service, and we've coded our cloud function to be able to interact with that service and respond with data coming back to our front end so we can see it. So if we're talking about our overall voice assistant that we're trying to build here today, we've kind of done step 1, right? Transcribe the audio into text. So now we know what it is, exactly what it is that the user said when they were interacting with our service. So the next step would be natural language processing. So with Watson, there are two things here that you could probably use to solve this problem, and we'll talk about both a little bit, but we're only going to be able to use one. So the two services that we could use here are natural language classifier and natural language understanding. Natural language classifier allows you to set up and train kind of a more traditional machine learning model, if you will. So you could give it phrases like, hey, what's the weather? What's it look like outside? What's the high temperature today? And categorize those, or classify those, I should say, as current weather information. And you could create other things that say, hey, what's the moon phase? When's the next full moon? What's lunar eclipse look like tomorrow? And those could all classify as lunar phases. That would help you kind of decide, hey, when somebody interacts with my service, they said this, and I want to do that, right? Because knowing whether or not I want to get weather information or sports scores probably depends on what my backend service is doing. So that would be extremely useful for making those decisions and would be a very good option. It takes a lot longer to set up and train the model and do all that stuff, so we're not going to utilize that today. I did want to talk about it, though. We are going to use natural language understanding. And one thing is, for absolute sure, you could probably make an entire career out of doing natural language processing. So talking about it for 5 minutes in a 1-hour talk probably does not even start to give justice to the field of natural language processing. But I think what you'll see is that we can get a lot of big wins pretty easily with utilizing some of these services. So if we click on natural language understanding, we get to the page to configure our natural language understanding, right? Which it kind of fills in some of the defaults for us as well, which looks really cool. And you can see some of the features that we're allowed to utilize with this service. So we can ask for things like concepts, keywords, sentiment, relations, entities, categories, emotion, and much more. I think there's one other thing, so that's much more apparently. But, so you can ask it for all those things. So you can give it a slew of text, you can give it a URL, you can give it HTML. It'll parse it, and it'll pick out whatever pieces that you ask for, those features, right? So if you say, hey, here's a URL, and I want you to give me the sentiment of it, it'll basically go get that URL, assuming it's public, grab the HTML, parse through it, and say, hey, well, that website you sent me to, CNN.com, for instance, was 98% negative, or 32% positive, whatever it may be. So there's a lot of cool stuff that you can do with this service, and we're going to touch on a couple of them very briefly. So we'll click Save there. This should look very familiar, right? This is, hey, here, this is how you interact with our service that we've just created, right? All right, service credentials, new credentials. Yeah, sure, add them, cool. More usernames and passwords that I don't want to share with you guys. Right there, so we'll copy those because we're going to need them. So if we switch back to our server-side implementation now, we can start to take the transcript that we got from step 1 and start plugging that into our natural language processing service that we've just created. So you can see there on line 2 that we're bringing in another provided library to us from Watson Cloud Developer to help us interact very easily with natural language understanding. On line 9 there, you'll see that I've created this method called getTranscript-from-audio. So all that that's doing, I just wanted to kind of extract it to get it out of the way so that it wasn't confusing, but that's all the code that we just did in step 1. Basically just moved out of the way. So we can focus on step 2. So we get the transcript and we say, okay, we need to generate some parameters here so that we can make a request to our service that we created. We'll give it the transcript and we'll say, hey, I want keywords, I want to limit it to 2, and I want entities, limit that to 2 as well. Obviously with the small phrase that we're giving it here today, limiting that to 2, more than enough information. If you're shoving the Bible at this thing and saying, hey, I want all the entities in this, you may want to ask for more than 2. But obviously I'll let you guys figure that out with whatever it is that your use case is. So very similar to our voice-to-text service that we created. Set up our parameters instantiate our service with our username and our password. Take that guy and say, hey, analyze with those parameters that we just said. The response comes back. We want to send it back to our front end, right? So again, our front end, very basic. It's doing the post when it gets the data. And now our service kind of looks something like this.
What is the weather in Sandusky?
It's loud. So we got our response back. So that's the raw response coming back from our natural language understanding. So you can see that we got keywords and entities. Those are the things that we asked for, right? So it picked out that the keywords in there were Sandusky, and it was 97% relevant, and that weather was also a keyword in there, but it was 32% relevant. The entities is going to be very useful for us. We're trying to determine where we need to get weather information for, and we can see that the text of Sandusky, it's a location of type city. Very cool. So given a string of text, we've extracted all that information. And like I said earlier, I would hate to have to write the regex to parse that to generate that data, right? Little developer joke for you. If you have a problem and you say, I'm going to solve this with regex, what do you have? Two problems, that's right. So if we ask this thing something else, right, something off the cuff, who are Donald Trump and Barack Obama? We can see that the entities that come back are of type person, and gives us some subtypes of celebrity, founder, actor, president, politician, things like that, right? So even if we're not trying to get weather information, this is just another example of some data that would be returned to you by asking it something else, running that through natural language processing. If we say, make a phone call to Jared Olson, it also comes back and it identifies that I'm a person, even though it spells my name wrong, but that's okay, I won't take offense to it. And I think that's pretty cool, right? That the fact that it can pick out, hey, this is a person that we're talking about here, not a resource either. So in that step of our natural language processing, right, we've configured up our cloud service, we've written the interaction for it, coded it up, and now we're returning that. So we can check that off our list, right? We've done our natural language processing. So the next step that we need to do is we need to take action, right? So we know that we're asking for weather information. We know that we're asking for the city of Sandusky. Let's go get some weather information, right? So what do you do when you need to find something that provides an API? You go to Google, right? So I Googled free weather API, and I came up with openweathermap.org. So you click sign up, create an API. Now you have an API key that you can get weather information from. Pretty cool. I won't take you through the steps of that. It's pretty boring. But if we go back to our cloud function that we've created, right? I did the same thing here. I extracted out the stuff that we did in the first two steps so that we could focus on this third step. So once we get the transcript, once we get the location, now we can make a request out to our API, which looks like that. Pretty basic API request response going on there. Give it my API key, tell it the location, and respond to our service then with the data that comes back, right? Front end, again, looks the same, posting up the data, getting a response back. And that starts to look like this.
What is the weather in Sandusky?
Cool. So now we have our weather information. So we can look at that, but I mean, it's pretty basic stuff in there. So we have high temperature, low temperature, average, sunset, latitude, longitude, things like that, right? So if we ask it, hey, what's the weather in Detroit? You can see that our natural language processing successfully picked up that, hey, Detroit is the city that this was said in this phrase. Now let's use that to go into our API service to go get weather information from Detroit. If we ask it, hey, what's weather in Columbus? Likewise, it can go get Columbus information. And what's the temp max there was 46 degrees. So that was obviously last summer that was the weather going on. Joking. So what we've done there is set up, set up our API and interacted with it from our cloud function and return that data now. So we're getting there, right? Now we've got a lot of data, and now we just need to respond with audio and some other data, right? Cool. So the last piece that we need to do is, again, underneath our Watson category here in our IBM Cloud. So we'll click on the text-to-speech button there, which allows us to set up our text-to-speech service, which should look very familiar to all the things that we've already created here today, right? So give it a name, and you can see that we can start to ask for some of the features that it allows us to do. So it supports English US, English UK, French, German, Italian, Spanish, Spanish North American, Japanese, Portuguese, and I think that's about it. So you can give it you can request that it generate audio for you in all those languages, and it'll do it for you. Very cool. So we'll click Create. Again, here's our page about here's how you use the service. We know that we need service credentials because we got to interact with the service. Blah, blah, blah. Click buttons, get username, get password. All right, and we're going to take those back to our server side implementation. So much like we've done before, right? Let's extract out some of the cruft of our first couple of steps here. We brought in a new library, or part of that library that allows us to easily interact with the text-to-speech, right? Yep, text-to-speech. So we're going to build out a string here that says the current forecast in whatever the location is something from the weather data with a high temperature of information from weather data, degrees. We're going to utilize that as the text parameter going in. We're going to say we want this to be the English US Allison voice, and that we want an MP3 coming back. So when we get the response back, this is the first time that we're not just going to blindly return it to our front end. We are going to do a little bit of processing on it here. So since we're sending across an audio stream, we need a base 64 encode that before we send it across the wire. So we'll encode that up, and then we'll put that into our JSON body here. So we'll give it the text, we'll give it the transcript of what we determined the person said, and we'll give it that audio stream going back as well. So our front end is the first time that it'll actually change. On a successful response now coming back, we're going to look for that audio file, or the audio stream that we send back now, and we're going to shove that into a audio tag, and then we're going to trigger the play on that audio tag so we can hear what it is that we created. So we'll do this example.
What is the weather in Sandusky?
And as you can see, this is just as fast as Alexa or Google or any of these others out there.
The current forecast in Sandusky is clear sky, with a high temperature of 8.6 degrees.
Cool. I think I was back in December, not last week. But anyway, so we're success, right? We've done it. We've done the full round trip. So what we've got is, or what we did there is we configured up our text-to-speech service. I always want to flip-flop those two. Speech-to-text, text-to-speech, whatever. Coded up in our cloud function, and now we're returning audio, right? Last step of our voice assistant there, right? Check. Awesome. So one of the things that gets asked about, well, hey, that's all really cool. How much does it cost, right? I say, don't care about it, just tell your boss to pay for it. Sometimes that doesn't work, but so the speech-to-text is, with the light plan, which is what we were using, I think you get 100 minutes of transcription a month for free. So obviously, if you're just toying around with it or trying to do a proof of concept, that's going to give you more than enough probably to play around with. Outside of that, you start to pay, looks like 2 cents down to 1 cent per minute, depending on how many minutes you process in a month. There is a premium option. My experience with the premium option is if you got to ask, you probably can't afford it. So, or you probably don't want to pay for it. The natural language understanding pricing is a little bit different, I guess you could say. So we were only giving it, what, like 80 characters or 40 characters, something like that. You know, what is the weather in Sandusky? So it defines a natural language understanding unit as 10,000 characters or less. So we would have consumed 1 unit for our 40 characters or 80 characters, whatever it was, right? If we say, hey, here's 17,000 characters, that would be two units. Then for the number of things that you ask it for, it multiplies those together. So if you have 1 text unit like we did, and we asked it for 2 things, that consumes 2 units, right? If you have 17,000 characters of text, that would be 2 units. If you ask it for 4 things, entity, emotion, sentiment, keywords, right, you would consume 8 units. And so that's the way that the pricing for that works. You start to pay, I believe it looks like 3 cents an NLU item, or sorry, 0.3 cents per NLU item. So the process that we did, each one of those would cost us 0.6 cents, basically. One of the other cool things with the natural language understanding that you can do is you can actually start to couple those things. So if you say, hey, I want entities and I want the sentiment of those entities if you give it a phrase like, let's see here, I love Star Trek, but I hate Avengers, right? It'll pick out Star Trek, or Star Trek, I should say. Probably, I don't know if it would pick up Star Trek. It would pick out Star Trek and Avengers as entities out of there, but it would tell you, what did I say? I love Star Trek and hate Avengers? I probably shouldn't have said that here today, should I? It would tell you the appropriate emotion for the specific entities as well. So you can kind of start to combine those together to get some pretty powerful information out of it, which is really cool. Lastly, the text-to-speech is priced based on the number of characters that you give it. So with the light plan that we're using, 10,000 characters per month. Outside of that, you pay 2 cents for every 1,000 characters that you send into it, which is pretty easy to calculate as well. So some of the use cases, right? We touched on this a little bit at the beginning, but I'd like to go over them again. Obviously we're giving the talk is about building your own voice assistant, and like I said, some people may have a use case for doing that, right? I don't want to pay Amazon because they're a competitor. I need to build my own, right? I can't use Alexa. IBM's obviously, if you're in the retail business, IBM's probably not a competitor, so you can utilize their cloud services to do that. Part of the real value in the talk, though, I feel like, is understanding all those pieces that we did, because there's use cases for that probably in our day-to-day work. We can go back to work tomorrow and utilize some of those services or similar services in our cloud provider to help us do our jobs better, right? So with the speech-to-text, obviously I needed it to transcribe videos to get better understanding out of the videos. Anything with an audio stream, right? Podcasts, voicemails, phone calls, meeting minutes, doctor notes, things like that, all could be transcribed and stored as text, right? Because an audio stream does you nothing when it comes to trying to do a search in Elasticsearch or store something in a MySQL database that you can do processing on it, right? You got to have text, because text is king when we're trying to do analytics on stuff. Also, educational, having a student recite something in Spanish, you could potentially even use another one of their services that we didn't talk about, run it through a translation service and translate it to English and see what comes out the other side, right? Crazy stuff. Natural language processing, whole slew of use cases. Some places where I could see that being a nice, easy win would be doing pre-processing to a search query, right? If I say, hey, contact information for Jared Olson, it would pick up that Jared Olson's a person, so maybe I want to search, boost my Elasticsearch query a little bit to give precedence to users, because I know this person just set up, or whoever is searching requested a person's name, right? Keyword extraction, right? If I give you a PDF, that PDF could be called jared.pdf. Well, what's this PDF about, right? Well, you could run it through natural language processing and extract keywords out of it to understand, like, oh, hey, this is about building your own voice assistant. Sentiment analysis gives you the information of how positive or negative a string of text would be. And I would be very interested to hook this up to a Slack channel and see what comes out of that and how well it picks up on sarcasm as well. That'd be pretty interesting to see, I feel like, because I'm always sarcastic. But lastly, with the text-to-speech, like I said, you could potentially use this in a translation, so they do offer translation services as well. So you could take in English, translate it to Spanish, generate an audio stream of Spanish coming out the other end, and do something like that, which would be pretty cool. Educational, you could use it as well. Visually impaired, I think that we talk a lot about accessibility when it comes to people, especially visually impaired ones. And there are a lot of good tools out there for those people, but anything that we can do inside of our web applications or phone applications, native applications to help that crowd could be potentially useful as well. Very, very appreciated, I'm sure. So I put a link to this in the bottom there, so you don't have to type that out, but that link should be in the Slack channel to all my slides. I am also on Twitter at Jared Olson. We do have all the code in there as well, so kind of like what we built out here, we did it in like 4 steps. I do have each of those kind of broken down individually, and that's all that I got. So, any questions out there? Any on Slack? No questions on Slack? We got one here.
So this one so far just does weather. If you're wanting to build one that's a little more full featured, is it just an iterative process of building this kind of same sort of thing with hitting different APIs?
Yep. So the question is, thing that we built here today is only doing the weather. And how do we start to transition that into something that can do other things as well, right? That's a nice summary of your question. I just want to make sure that we get that so the other theaters can hear it. So you would probably utilize that natural language classifier is what I would do, so that NLP service that I talked about. So you would build out your model and say, hey, these phrases mean this thing, which you would then wire up to go get sports information. You know, these things mean weather, do that to go get weather information. So if you've ever built an Alexa skill, that's kind of where you start with an Alexa skill, is it's already made the decision for you. So they've processed the audio, they've determined, okay, this person wants sports, this is the intent that you're doing. So that's kind of where you get dropped in when you're doing an Alexa skill for something like that. But you would probably want to do the classifier so that you could pick out and say, okay, this is the intent of the user, right? They want weather information, and go that route and build it iteratively, like you said, would be nice as well. Cool. Another question.
Play around any with carrying context or session?
So the question is, have I played around at all with carrying context or session? No, I have not. I guess you would probably start to utilize cookies or something like that.
Well, yeah,
Playing around.
You say, what's the weather in Sandusky? And I say, what about Columbus? What do you want to know about this? Like, well, I just asked about the weather.
Yeah, yeah. No. So I mean, the short answer is no. I haven't played with that, but I'm sure that there's creative ways there that you could accomplish holding open a session or doing some stuff. I know like a lot of the Alexa skills, they'll ask you a question, you respond, and then it'll tell you, oh yes, that was correct. All right. No other questions. Thank you guys very much. Appreciate it. You guys enjoy the movie today.